All right, we're going to kind of describe aerobic cellular respiration using some water balloons here. So what we're starting off with is a molecule of glucose, and this glucose is made up of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. And this molecule is going to go through a process called glycolysis. All right, glycolysis will cost us -2 ATPs. So we're going to start off at a deficit of -2 ATPs. And when we go through this process, we're going to end up with pyruvic acid. We're going to split this glucose molecule in half and end up with 2 molecules of pyruvic acid. All right, so the next part of the process is the pyruvate oxidation. So if you notice here, the pyruvic acid is made up of 3 carbons, 4 hydrogens, and 3 oxygens. That leaves us with 4 extra hydrogens. Okay, so this process generates 2 ADPs per pyruvate. So when we subtract the 2 from that, we end up with a net gain of 2 ATPs total. We also reduce NAD to NADH, so we're going to take one of those from each one of these. To NADHs. So that's where 2 of our extra H's go. Okay? And the next part of this process of the oxidation, the pyruvate molecule gets chopped up and becomes acetyl-CoA. Now when we make our acetyl-CoA is a 2-carbon molecule. So if you look, we have 3 carbons, and in this process of taking one of these carbons off, we're going to take 2 of our oxygens, and we're going to make CO2. Okay, so then we'll put these 2 carbons with the acetyl-CoA, and our other extra hydrogen molecule is going to come over here. We're going to make another NADH. Okay, so just one pyruvate makes 1 carbon dioxide and 1 NADH, and we're going to use the rest of these later. Alright, so here's where we start the part of the process, which is the citric acid cycle, or the Krebs cycle. Now this acetyl-CoA will combine with a 4-carbon molecule called oxaloacetic acid. And when it combines with that molecule, it becomes another 6-carbon molecule. We're taking these 2 carbons, combine it with the 4 from oxaloacetic acid, and we're going to create citric acid. This is the same citric acid that we find in lemonade and orange juice. Okay, so this citric acid will then get oxidized, and this is where we take our 6 oxygen molecules, and we're only going to use half of these for now. Remember, we have a whole other pyruvate to go to. So these 6 O2 molecules, so O2 is 2 oxygen atoms, so 1, 2, 3, 4, 5, 6. We have 6 O2 molecules, and so what these are going to do is these are going to combine, and we're going to make some more CO2, and we're going to make some water. So the citric acid then gets oxidized, okay? And this process of oxidation creates 3 more NADHs, 1 ATP, and 1 FADH2. Okay, and all of these, all the NADHs that we made before, so we have 1 there, 1 there, 1 there, and 3 there. And remember that from this line here all the way over here, we're going to repeat this whole process twice, so we're going to get double the amount of everything. So we'll end up with 2 NADHs here, 6 of them here. We'll end up with 2 ATPs and 2 FADH2s. Okay, so Each NADH is going to give us 3 ATPs. So we have a total of 10. Okay, we're going to count them. 1, 2. Remember, from here forward, we have 2 each. 3, 4, 5, 6, 7, 8, 9, 10. So we multiply that by 3. Remember, NADHs give us 3 ATPs, so that's 30. Okay, so let's count our ATPs so far. Minus 2, plus 2, that's 0, and plus 2, so we have 2. When we come over here, remember everything on this side of the yellow line we double, so that's 2 ATPs there, so that gives us 4, so we're at 34. Now we're going to look at our FADH2. FADH2 gives us 2 ATPs, so we multiply that by 2, which is 4. We had 34, so all of this stuff goes through the electron transport chain, and that's where we get our 38 ATPs. Alright, so what do we do with this leftover stuff? So this oxidation process takes these 2 carbons back off, and we're going to make 2 more CO2s. Okay? So those are there for CO2 making. So we're going to come over here and we're going to make one and 2. So we make 1 CO2 from pyruvate oxidation. We make 2 more CO2s from oxidizing the citric acid. So remember, we do everything on this side of the line twice. So we will end up with 6 CO2 molecules. We have these left over, so we have 2 hydrogens, and 1 oxygen, H2O, water. Okay? H2O, there's water. Okay, and now we have our NAD. We're going to take the H off of that. And this NAD, we're going to take the H off of that too. This NAD is going to go back into the glycolysis process and be recycled, as well as that one. We'll take these last 2 H's. And one of our oxygens, and there we have 3 more water molecules. Now remember, we're going to repeat this process twice, so all of that there is going to give us another 3 CO2s and another 3 waters for a total of 6 CO2 and 6 H2O. Right, so off camera I went ahead and completed that process for the other pyruvic acid. So now, so you can see we have our 6 CO2s, no more oxygen left, no more glucose left, and our 6 waters. And this is the simplified version of aerobic respiration. Alright, so that process explains cellular respiration. It's important to take home out of that we have to keep our cells perfused and oxygenated to deliver that oxygen which is necessary for the cellular respiration. Oh, faster, faster, there you go. Oh.
But I'm getting the most shots. Oh! Oh, good. Ah!
Oh.
Oh!
Let's try you.
Oh.